Thank you very much, Karen. Can you hear me? And can you see my screen?
As we can hear you.
Can you see my screen?
Yes, I can see you. See
Thank you
you.
very much. So, thank you very much for the introduction. I guess that saves me a lot from my first slide. I would just like to thank everybody for being here today, and I'm very happy to be talking to you today about the topic that is related more towards usage of AI in specifically in the construction industry, and specifically in something that we call life cycle analysis. So just to go on from the introduction about me, I have been very fortunate to be working in both academia and academic hat and in industry as well. And that has really solidified this merge between development in technologies like AI that I was very fortunate to be in and applying it directly into industry. So if I may go forwards, I would like to talk today about three parts to my talk. First of all, what is life cycle analysis? What are the challenges that we have in the built environment? And then how do we generically use AI in the built environment at the moment? And then finally, I will go a little bit into more detail about using machine learning algorithms specifically for life cycle analysis of buildings. And happy, of course, to take questions afterwards. So regarding the challenges that we have in the built environment and what is life cycle analysis, of course, this is very familiar to everybody. We have huge problems worldwide when it comes to construction and regarding the built environment, from very poor quality buildings, slums, very poorly planned neighborhoods, which induce crime and induce all sorts of diseases and all sorts of problems. We have the climate change problems with wildfires and glaciers now melting and the soil drying up, which causes us problems. We have the pollution that is coming out of the buildings, which causes even more pollution to the soil and the earth and water, as you can see in front of you. All living conditions which are unlivable, unmanageable. So this is globally. But if we take a few statistics, they are pretty horrifying. So if we know that the built environment or the construction is responsible for consuming 50% of the world's raw materials, it is responsible for 40% of the world's energy consumption, 30% of the world's carbon emissions, and 30% of waste that comes out of it. Most of it goes to landfill, unfortunately, and not even reusable. This is pretty horrifying picture. And I think it needs a very pertinent solution to it. Our discussion today will be how AI can help with that, or is it helping, and how can it help forwards? If I go even a little bit deeper into the statistics of the energy consumption, well, in this chart it says 35, here it says 40, but they're very close. You can see the division between non-residential, residential buildings. Residential buildings is quite a problem, actually. And the construction. So just constructing itself is not that big of an issue, but it's operating the buildings that is the biggest problem. And this is where life cycle analysis comes into place, which I will talk about later. Same thing for emissions as well. As you can see here, it is divided up into the non-residential, residential, and so on, and construction is only part of it. Okay, this goes into a bit more deeper regarding the analysis of buildings. And this is what life cycle analysis is. It analyzes the different components of the buildings. And this is a statistical analysis that I performed on my own projects, our buildings that we have been managing. And if you look at the blue line up here, which is basically the benchmarks that are required by the European Union, for example, since I'm in Europe at the moment. Sorry. And the red line shows you how efficient current buildings are in comparison to the benchmarks that the EU require in carbon and energy, in indoor climate conditions like U values and air tightness and daylight and lightning and temperature and so on, water quality, air quality, pollutants, and wastes and costs. You can see yourselves how inefficient buildings currently are. Okay, so much talk about problems. So where does life cycle analysis come into place? Life cycle analysis is basically a method that we use to evaluate the environmental impacts that our buildings have at different life cycle stages. So what is the current impact on the environment that the building has, and how we can improve it in terms of what I just showed you, in terms of reducing carbon emissions, reducing pollutants, reducing energy, improving indoor climate, improving water quality, and so on. All of this is part of what's called life cycle analysis. Sorry. The important thing is that this wheel here shows you what aspects of the life cycle we can take into consideration to improve. So can we improve the way that we extract raw materials to reduce carbon and energy, let's say? Can we improve the way that we transport so that it is more local and we reduce carbon and energy in doing so? Can we improve the manufacturing process and transporting to construction sites so that, again, we reduce these things? While we are constructing, can we do the same? And then let's go on to the next phase of operations. The emissions themselves from the buildings. When you come to maintain it or repair it or renovate it or replace objects or just generally use the buildings, can we improve our behaviors? Can we do better installations, better materials in order to reduce the impact on the environment? If then we need to disassemble the building or demolish it, does it all go to landfill, or do we account for reuse of the materials, and in the disassembly we don't emit a lot of carbon? Or transport to waste disposals and so on. So all of this has an impact in what's called LCA. So please allow me to use the word LCA from now on. There are more devastating actions. I'm sorry, I'm still going on with the problems, but it is essential because the solutions after that will show that this is very pertinent. The final problem that I want to allude to is the effect on the environmental impact factors. Those of you who might be aware of them, we have 16 main ones, which look, I don't know, does that really connect to construction? I mean, toxicity, eutrophication, acidification, ozone. How does that connect to construction? Actually, it does. I'll give you a simple example. Did you know that the alarms, fire alarms that we have in our indoor spaces, if they are damaged, they can actually produce ionized radiation? That is just one example of it. So definitely unhealthy, causing human toxicity, could be cancerous, and other problems. Eutrophication is known as having a layer of greenery on top of our water sources, which prevents oxygen going down to underwater organisms and life. How does that connect to construction? Very easy. All of the pollutants that seep from the construction sites into the soil and into the water allow the nutrients in it for algae and so on to grow to prevent oxygen from going down. So all problematic things. All right. So how can we use AI then in construction in general? Or how are we currently using it? So it has many, many different applications. So first of all, of course, in improving design. So you can have generative AI produce different options for design, which help you find solutions that would be more sustainable for the environment and better for the indoor climate and usage of the users. It can also be used to reduce construction wastes, construction logistic transport, health and safety, and so on. It can also be used for smart operations. So the building itself becomes very smart. It adjusts the temperature, it adjusts the lighting, and so on in order to be suitable for the users and not over consume with carbon and energy. Also in offsite manufacturing, how can we produce modular design or modular prefabricated items without too much carbon and energy consumption? Material design, structural design, so that it will be resilient. And of course, using circular materials so that we can reuse them later. AI is now currently being used for all of that to help designers, constructors, and operators to better function in that way. These are some pictures from things which are currently being used using AI. So of course, we've probably heard that AI can be used to detect structural failures ahead of time for predictive maintenance in order to make buildings more resilient. That is sustainability, by the way. To sustain something is to keep it alive. So that is part of it. Another usage is using AI in heritage. AI has been used, as you can see here, to detect different types, to first of all classify and group all of the stones in that particular building's facade, and hence identify a strategy for maintaining them, replacing them if need be, and the age of them as well, and their level of deterioration. That is an incredible usage of AI in heritage. It has also been used to detect health and safety issues on site. As I will talk later, you can classify just from images whether there is a hazard in health and safety on sites or not. You can also use it to survey very, very quickly the amount of soil that needs to be removed, extracted, how to do that, where to position your tractors in order to most efficiently do that. Also maintenance inside spaces, design of different options which are more sustainable. So these are all currently different applications that AI is being used for. Now, if I go a little bit strategic, globally wise, we are all aware, for example, of the global warming that we have had almost 2 degrees since the 1850s till today, in just 150 years. And this has a lot of impact on buildings and from buildings. So how can AI help with this more global agenda for the built environment? Well, AI can definitely globally detect the percentage of energy efficient buildings all around the world. Where are the hotspots of inefficiencies, why this is so it can begin to connect to different environmental factors which are affecting why those buildings are inefficient. And then there could be planning for low emission materials. How is that possible to procure in different global areas around the world? How are the different behaviors, cultural, maybe traditions, presence of different equipment, design methods used in different areas around the world. How are these affecting the sustainability of the built environment? Transportation routes, like for example, the current wars in the Middle East are preventing a lot of transportation to be happening in the Suez Canal. This has a huge impact if ships are not able to take that shortcut and go around a continent, for example, in order to deliver materials. Again, this will help with disaster mitigation and prediction of what the climate could be. AI is definitely useful in all of that. It is also useful in the global picture regarding greenhouse gas emissions. In addition to what I just mentioned in the previous slide, AI can also detect globally where are the hotspots of wastes, the way that they are being managed, the problems with them, how they can be mitigated, maybe how different regions around the world can help with that. So collaboration between nations, circular economy, how this is happening worldwide. Are there any carbon capture technologies being used worldwide? Why are they efficient in others? Why they are not? AI, when trained on all of this, can definitely help find those relationships and help with this. Okay, and finally, I just wanted to show how current off-the-shelf AI tools are being used in the construction industry at the moment. I mean, we have tens and tens of off-the-shelf AI tools. Of course, we know like ChatGPT and Copilot, but there are others that can be used in the planning, design, construction, and operations. There are many names here which you can see which are maybe familiar, but there are others which are not as familiar, but they are used in the construction industry. So this brings me to my third and final part of my presentation. And this is about what specific machine learning algorithms can be used for life cycle analysis in buildings. And this is where I go a little bit deeper into a practical application that we actually did. As part of a funded institutional links project that I did in collaboration with the Egyptian government, we were tasked to use digital twins and AI in order, not tasked, but this was our objective, in order to improve the renovation of heritage buildings. And as we all know, Egypt has one of the wealthiest reserves of heritage in the world across different eras, from the ancient Egyptian, Roman, Greek, Coptic, Islamic architecture, and so on. So this was an example project that we were working on, a castle. I will not go into its details, but I will go into the AI aspect of what we were thinking about. So one of the questions, that's just one of them, that emerged when we were talking about renovation. If we want to renovate and use building materials with least embodied carbon in them, so this is a graph showing the different materials and their embodied carbon, okay? As you can see, the ones on the right here have lowest embodied carbon in them. However, there arose another question in addition to that. If we had the flexibility to choose which materials, and we were not to replace using specific materials, can we choose the ones which are also highest in recyclability impact? So they would be both low in carbon footprint and high in circularity. Can we do that? Well, the only solution to do that was to use AI to do this analysis. And this was one of the questions, just one of the issues that AI was able to be helpful in. If I just quickly review with us, and of course, this is all common knowledge to everybody here on the call, the different types of AI available. The one which I would like to focus on today is machine learning and its usage of different algorithms, specifically supervised, unsupervised, and reinforcement. These were the ones that we focused on the most in the project that I am alluding to, and I'll show you how. So if you allow me, I will just stay on this slide for a little bit because it contains the different solutions that we were trying to do, or that anybody can maybe try to use in their own projects. So as we know, of course, with supervised learning, if I start with supervised learning, it is about feeding the AI machine or agent with a lot of known inputs with known outputs. And this is how it learns to classify or group things based on these known inputs and outputs, or predict, which is another application that we call regression, of course. And that is prediction based on known parameters. So the AI learns to predict based on certain parameters. So how were we able to use that in our projects, or how can that be used in general? Okay. So these are examples of how it can be used and how we try to use it. For example, classifying the buildings or the materials in the buildings into low, medium, and high environmental impact. So that material or that building has a low, medium, or high environmental impact based on the data that we have on them. We can also use AI classification for diagnostics and forecasting to forecast, of course, and that's one of the most logical one, the energy consumption patterns based on the legacy data or historical data that you're collecting from the building. You can also be able to use image classification, like just by looking at how things are implemented in the space, how the windows are fitted, maybe problems in the walls or in the fittings or the mechanical equipment or electrical equipment and so on, immediately AI would be able to recognize where the inefficiencies are that could cause thermal inefficiencies, loss of heat across the walls, with types of insulation there, for example, the way that things are fitted that would cause more energy consumption to counteract for losses of heat and so on and so forth. So that is definitely something that image classification can help with. Also to classify wastes that are being produced, whether some of them can be reused, disposed of, and so on in a sustainable way. A fourth way is data validity and security. So the AI would be able to identify whether there are issues in the data that is being collected, especially if we are using IoT sensors, how that data can be cleansed, formatted, and reused in a better way. So all of this are examples of using classification of supervised learning. If we want to look at usage of regression or prediction, so I'll start with here. So we can predict the inventory that is useful for the building. So we can predict which materials, based on their carbon emissions and based on their embodied carbon, what would be the best to be used and which would be most circular, as I mentioned before. We can use it for process optimization. So predict what energy patterns we would have in future if we change certain behaviors in the usage of the space or install certain equipment or materials and so on, or change design. We can also estimate the expected life of the components or the expected life of the building itself, especially in heritage assets. It is also used for risk evaluation of what are the risks in case of using different types of transportation or different usage of the spaces. And something which is very odd is usage of it for market prediction. So what is the expected price of the of the asset in that particular area based on its energy consumption, for example. Now, if we go on to unsupervised learning is all about feeding data which is unknown. So maybe unstructured data, we don't know the outputs of the data, it's just inputs, and allow the AI to extract its own patterns and its own conclusions from the input data. So how can we use unstructured data for life cycle analysis in buildings? We can use it for clustering and dimensionality reduction. Clustering is when you also predict, but it's not based on parameters, it is based on patterns that have been identified from unstructured data. Can that be used in life cycle analysis? Of course. It can group buildings with similar environmental profiles and maybe find a relationship between their profiles and their environmental impact, and hence try to identify where their problems are that need to be identified. For example, in large urban planning areas. It can also recommend systems to use, like software that can be used. It can also be used for talent acquisition. So it can maybe identify the best people in the teams to handle certain things based on the work that they have been doing and their levels of production. It can, regarding reduction or minimalization of the data quantities and finding best outputs out of them, it can be used to find anomalies in large data sets that are coming out of IoT sensor telemetry data. It can be used to identify best features in certain design or construction or operations inside buildings. It can be reduced to used to compress the amount of data in documents, maybe from the data that we have from agencies or from planning permissions or any data that we have on databases on buildings, and find structured relationships between them. And lastly, I would like to talk about reinforcement, because reinforcement learning is one of my favorites, actually. As we all know, reinforcement learning is all about trial and error. So you tell the AI whether this is working or not, and it improves its suggestions or optimization plans for you based on it. There are many uses for reinforcement. Most of the tools of AI that we have right now, even with ChatGPT and Copilot and others, they do use an element of reinforcement because they shape the solution that they give you based on your feedback. So this is definitely one of my favorites, and it can be used for dynamic decision making, optimizing the operations inside the buildings based on the user preferences from light and temperature and heat and so on, but also with taking into account least consumption of energy and carbon. It could be used for automation and robot navigation. So how do you drive the best way to work a robot? 3D printing, bricklayering, and so on, based on feedback that you give that robot. Design optimization, we mentioned that before. Even in gaming, you can use VR for building management systems in order to get user feedback, user preferences, and improve the indoor operations based on that. And lastly, we have been using it for future bid optimization. So how do you write a best bid for pricing, best building performance, and include that in the bid? So these are all things that can be done in life cycle analysis using AI algorithms. And in this next slide, I have written the names of the specific algorithms that can be used to enable that. Of course, I'm happy to share this with anyone who is interested in this, but this is some really effective research and applications that we have been doing and currently involving as well in some major projects across Europe. Funnily enough, Dr. Jose said in the previous presentation about roles and employability. I just wanted to allude very quickly to how that impacted our roles as well on our project, our heritage project that I just showed you. So ideally, when you think about what skill sets you need for a construction project, you are usually faced with these on the left here. Normal engineers and managers and building information modeling specialists and renovation specialists, environmental specialists, and so on. But what we realized is that with the introduction of AI, we needed even more skill sets, the ones on the right here, to employ or at least to make sure that our employees had them. So to reiterate what Dr. Jose was saying earlier, AI can actually open more opportunities for skill sets. It's not just about taking people's jobs away. It also opens many opportunities. I mean, even just looking here, you need a prompt manager, someone to manage what you actually put inside off-the-shelf solutions if you're using them, or if you're making your own bespoke solutions, you need, of course, coders and data mining analysts and visual analysts and trading analysts and predictive data analysts, so many different roles, and ethics as well, as also Dr. Jose mentioned earlier, in addition, of course, to security. So I just wanted to allude to that. This is an additional a few roles which I added here. I'm not going to go into them. If anyone is interested, I can, of course, share that with them. But to finalize my talk today, I just wanted to say that it's very interesting that we are doing all of these applications now, whilst we are still here almost like between stage 1 and 2 of of artificial intelligence, the narrow and the general artificial intelligence. It scares me, but also excites me to think what would the possibilities be if we go as far as super intelligence, which is what we see in sci-fi right now? What would the possibilities be in future in something like that? And with that, I am happy to take on any questions if anybody has any. I hope that this was interesting, and I hope you have a great day going forward.
Are there any questions?